Namaskara, good evening, and welcome to this evening's BIC Streams session in collaboration with the Infosys Prize, Making Roads Safer by Making Drivers Better. This evening, we have with us Professor Hari Balakrishnan, Fujitsu Professor of Computer Science at the Massachusetts Institute of Technology, talking to us about what the session is titled after, Making Roads Safer by Making Drivers Better. Professor Balakrishnan won the Infosys Prize 2020 in Engineering and Computer Science for, and I quote this citation by the jury, his broad contributions to computer networking, his seminal work on mobile and wireless systems, and for commercial use of mobile telematics to improve driver behavior and make roads safer around the world. The Infosys Prize is an annual award established by the Infosys Science Foundation to honor outstanding achievements of researchers and scientists across 6 categories of sciences. Each prize carries a purse of $100,000, a gold medal, and a citation. This talk is a part of the Infosys Prize lecture series, which are public talks delivered by Infosys Prize laureates and jurors. The lecture series covers a wide range of topics on the cutting edge of science and research. The aim to inform the public and inspire young researchers and students to make their passion their profession. In conversation with Professor Balakrishnan post the lecture, we have K. Jairaj, who has held several key appointments in the infrastructure, energy, transport, and urban development sectors, including Principal Secretary, Energy Department and Chairman of BESCOM, Managing Director, Bangalore International Airport Limited, Managing Director, Karnataka Power Corporation Limited, Managing Director, Karnataka State Road Transport Corporation, before retiring as Additional Chief Secretary, Government of Karnataka. And with that, I hand over to Mr. Jairaj for opening comments.
Thank you very much, Lekha, and good evening to all our friends in Bangalore, and good morning to Professor Hari Balakrishnan. It's a pleasure to be here and to share this stage with Professor Balakrishnan. I'd like to thank N.R. Narayan Murthy, co-founder Infosys, and Ravi for having invited me today. I think NRN may have been prompted to invite me because of my experience as Commissioner of Bangalore City and as Transport Commissioner handling transport regulation in the state. The modalities have already been explained by Lekha. After this very short introduction by me, Professor Balakrishnan will make a presentation of about 50 minutes, I think. And then we'll have a conversation between the two of us for about 10 to 15 minutes. And then have an active Q&A session, which can take place thereafter. As was brought out in the introduction, Professor Balakrishnan is a distinguished academic as a professor at the MIT. But you know, what is interesting to me is that he has straddled many worlds. He's also an entrepreneur, having co-founded the Cambridge Telematics, which offers real-world solutions rooted in artificial intelligence in terms of mobile telephones, smartphones, which shape driver behavior and also incentives which insurance companies give. And I'd like to tell Professor Balakrishnan, Professor, in Bangalore, we are really looking for a magic bullet to solve all our transport problems. To a public which is very weary from the kind of congestion and accidents they see around them, Bangalore is perhaps the most congested city in India. And so in this context, I would like to ask you, sir, how can technology really make a difference? Would it be natural for us to be skeptical in terms of using technology to bring about these major changes? Particularly, you know, we spoke about behavioral matters in the context of what CMT is doing, where social capital is lacking, as in our context, how can behavioral changes take place? Those kind of thoughts occupy my mind as I listen intently to what you have to say. But by way of context, without taking too much time, I would like to say that, Bangalore is spread over 700 square kilometers, and it has about 14,000 kilometers of road stretch. Some parts of our city are absolutely congested. We have cheek by jowl buildings, and there is severe competition for road space among a variety of traffic. In fact, that's a very interesting point that the growth of vehicular traffic in Bangalore has been astronomical. At the turn of the century, we had less than 500,000 vehicles in Bangalore on our roads. Today, that number is 8 million. Think about it, 8 million without substantial increase in the road surface. Out of this, 70% of the composition comes from two-wheelers, and about 1.5 million cars are on the road and 50,000 buses. This is because of a preponderance of private transport over public transport, which is quite inadequate to meet the needs of the people. We have a very sorry record when it comes to road accidents and fatalities. Last year, there were 5,000 accidents on our roads, and we had nearly 800 deaths. And of particular consequence is that pedestrian deaths amounted to 15% of the total deaths, which means that they are the most vulnerable road users that we have in our city. And what may be of interest to you, because we are talking of behavior, 40% of the 40% of the accidents in the city are attributed to drunken behavior, and a significant portion is also attributed to rashness on the part of drivers. Here is the interesting thing, Professor Balakrishnan. The peak time for accidents in the city are between 6 to 9 p.m. and midnight to 6 a.m. I wonder if there's a pattern in that. And Sundays are where maximum number of accidents take place. Saturdays are the minimum number of accidents. So in the context of all these issues, I would like to say, and I know that you have a very substantive presentation before us, that there is no question of the validity of the technical solutions that you have proposed, because obviously they have passed through very rigorous muster. But I would like to, on the basis of my experience and what I undergo as a commuter and user in Bangalore, posit 4 guideposts, so to speak, for your consideration. The first is in terms of goals. Is it proper for us to ensure, posit, that we should have orderly traffic movement in the city, despite the heterogeneity of traffic, despite the diversity of vehicle users and the adverse road conditions that we have? If so, how can we fuse technology in order to achieve these goals? Then in terms of policy, which is my second guidepost, we notice everywhere a failure of enforcement. Enforcement in terms of traffic regulations, enforcement in terms of fines, licensing, fitness regulations for vehicles, and so on. In fact, one estimate is that there are more than 2 million drivers on the streets of Bangalore. It is a moot issue as to how many of them are actually licensed. So in the context of policy, how can technology be used to strengthen policy implementation? Thirdly, about legislation, I need to ask you this. Should the state mandate and say that there must be a compulsory move towards public transport, or there must be alternate daily use of private vehicles, mount some kind of vehicle surveillance, or cap ownership of vehicles as they do in Singapore? Would that be a way forward, and can technology assist the state in that endeavor, or does it amount to surveillance of some kind over the citizens? And finally, I read that incentives shape driver behavior in the US in terms of the pioneering work you have done and the way insurance companies react to premiums. Okay. My question is that when there is an absence of social capital here, how will these positive incentives work in our context? And for that matter, is it only negative incentives which will work, such as, exemplary punishment for drunken driving, for rash behavior, for knocking down pedestrians, and so on? And if that happens, can we use technology for this purpose? So these are, Professor, a few guideposts that I thought that I'll pose before you as an anguished Bangalorean. And now over to you, sir. After your presentation and comments, we'll have a short discussion followed by Q&A. So Professor, it's a real pleasure to have you with us and look forward to your presentation. Thank you.
So Mr. Jairaj, these were excellent questions, and I look forward to our discussion after my lecture here. I want to start by thanking the Infosys Science Foundation, not only for honoring me with this prestigious award, and to the jury for selecting me, but also, more importantly, the Infosys Science Foundation for really creating a culture that celebrates research and celebrates researchers themselves. And this lecture series is something that I have been looking forward to. And really, it's an important aspect of communicating to the public, especially to younger population, the excitement of research, the ability to have fundamental questions answered by research that then lead potentially to an impact on society as well. I'm an applied researcher. I work on computer science and artificial intelligence, and I have been fortunate in being able to make contributions to computer science, as well as using computer science in the area of transportation. But before I start with my remarks, I think I would be remiss if I did not spend a minute just talking about the situation with COVID-19, particularly in India. It is a terrible, unbelievably, unprecedented, very, very difficult situation. I think we all know people, friends, family, and others who have been affected. And I hope that we are able to come through this. I have every faith that with the hard work of the medical workers and all of the other people working on it, and all of us being able to contribute in whatever way we can from the sidelines, that we will come out through it. And I think we all have family members, friends, etc., currently in trouble, and my hopes and my thoughts and prayers go out to them. So let me now talk about a different societal problem related to our road conditions. And the thesis of this presentation is making roads safer by making drivers better. How the combination of computing technology, especially with sensors and data from sensors on mobile devices, combined with artificial intelligence and behavioral science, which is a key aspect. It's not just about technology, it's about people. It's about understanding human behavior and providing positive incentives, in my view, to improve human behavior. It's not to say negative incentives are bad, but that combination of positive incentives with the right technology could potentially make a difference. So my own journey into this field, what is a computer science scientist doing in the field of transportation and road safety? It's a very good question. And it turns out that the answer relates to data and the models that one could develop from that data. And my own journey into this field, there's a personal story that I would like to share for a few seconds. When I was a graduate student, one of the things that I would do to avoid working on my research and thesis was to play cricket. And every graduate student needs a thesis avoidance strategy. And I played in a league in Northern California, near Berkeley in California. And I was involved in a car crash. There were 5 of us in a car. Driver was one of my teammates, lost control, spun around, hit the side on a highway. Then we rebounded into the middle of the road, and fortunately there were no other cars nearby, and the ones that were coming behind stopped. And, I've talked to a lot of people who've been in crashes, and they tell you that time sort of goes slowly at that point. Somehow the brain goes into a mode where it's absorbing everything. And that absolutely happened to me. And very recently it happened to a relative of mine who told me the same thing. And I was just taken back. I still remember from 20 plus years ago, 25 years ago, what happened. I still remember the color of the highway sign. I remember the barricade and so on. So it's just one of those things that I think we all know people who've been in a crash or have been in one ourselves. Millions of people are not so lucky as I was. This is a worldwide problem. 1.35 million people die annually, and tens of millions injured. The World Health Organization doesn't even have accurate statistics. In many countries, there's not really good statistics on this. So the injuries are estimates. And in many countries, even the fatalities are estimates. And it's a really global problem. It affects wealthy countries, it affects middle-income countries, and it affects low-income countries. And some numbers are shown over here as a fraction of per 100,000 of population. And the cost is not, the most important part of the cost is human cost, but there's also an economic cost. The statistics are hard to come by, but I read recently while doing some research about India for my presentation, most of my work is rooted in data from 25 countries. And today I'll talk about the United States. I want to talk about how we can collect data from India as well near the end of this presentation. But while doing research on India, I read that traffic accidents cost between 3 to 5% of GDP, according to some estimates. So it's a huge amount of money. And 60% of the vehicles are in low and middle income countries, and they account for 90% of the fatalities. So I wanted to show you some statistics comparing the United States, where a lot of my presentations data is going to come from and the research is going to come from, and India, just so you get a sense of the problem. So per population, per 100,000 people, the US is about 13 fatalities per 100,000. I'm going to focus on fatalities here, not injuries. Those statistics are, the gap is even larger, but those statistics are a little bit less reliable. And in India, it's about 16 per 100,000 people. Now, the statistics depend on where you look. There are statistics by different agencies that give different numbers. The WHO organizes them and provides a range, and I just picked the middle of the range for each of these. So it's about 16 per 100,000 versus 13 between India and the US. So you might say, well, it's not doing so badly. But the thing is, it's really important to understand the context a little bit better. If you look at the total aggregate number of kilometers driven, these are the numbers. Now, I initially started by looking at the number of vehicles. Now, India has a large number of vehicles, and it's grown dramatically, as Mr. Jairaj said. We have about 295 million vehicles in India, the bulk of which are two-wheelers. In the United States, we have about 286 million vehicles, the bulk of which are cars. But you look at the total number of kilometers driven per year, India has 3.5 million kilometers versus about 5.1 million kilometers in aggregate driven on our roads. And India, I believe, has the third largest road network in the world. The US is the largest road network in the world. So now if you look at these fatalities, so India is roughly about 210,000 in the middle of that WHO range versus 41,000 per year in the United States. And you normalize that by the number of miles driven, number of kilometers driven, my calculations are that India has roughly about an 8 times higher fatality rate compared to the United States when you normalize it by the distance driven, which I think is probably the right way to be normalizing this data. So there is an order of magnitude difference. And my hope from this discussion is to obtain partnerships, potential partnerships with groups in India where we can try to work together to bring some of the ideas that I'm going to talk about. And I'm not going to just throw them over the fence, to really collaborate and adapt those ideas to the Indian context, whether it be Bangalore, Chennai, Mumbai, or any other location in India. So that's really my ulterior motive, and hopefully an important motivation for what you will take away from this talk. Now, why do crashes happen? A lot of times, people think it's the vehicle failure and so on, but the predominant reason for the crashes, and this I believe is worldwide phenomenon, is it's driver human error. 94% or more of crashes in the United States from the NHTSA, which maintains the statistics, is attributed to driver errors. And I want to talk a little bit about what that means. And here's an interesting one. Mr. Jairaj talked about pedestrian fatalities. I went and we got data from the United States. And this goes back 30 years of data here. I start from 1990 and I go on. And I just look at pedestrian fatalities on our roadways. And you can see that it went down and down and down. And then 2009, and then it started going back up and up and up. And this, I believe, is true across many different countries. But this is US data, which I think is quite reliable. And the question you should ask is, what has happened that we more or less wiped out 30 years worth of safety in automobiles? Automobiles now come with all sorts of warning systems, and certainly technology has advanced. What has happened? What happened in 2009? Well, for one thing, the world's recession hit the world. But okay, well, you could say maybe the amount of distance driven dropped during the recession. But then this fatality rate for pedestrians is going up and up and up and up. So what's going on? So if you dig in a little bit more, what this picture shows is I took the same data in the blue line and I just looked at it from 2004, and I also overlaid it with bicyclist fatalities in the United States. And that's sort of held steady, went down a little bit, and again started going up again 2009. So what happened there? And you can see at the bottom, there's a very interesting correlation. The bar graphs at the bottom plot in number of million units, with the scale is on the y-axis, on the right side. It's the growth of smartphones. In 2009, it's sort of, the 2007, the iPhone came out. Shortly thereafter, there was Android. And then now we have these phones that have become a part of our body. They become a part of our existence. People look at their phones all the time without even realizing it. And people are starting to do that while they're driving. And a hypothesis that I think is pretty reasonable is phone distraction a significant factor in road crashes? So that's really part of the thesis here. And it turns out the answer, I'm not going to keep it like a mystery here. It is a significant factor in the research that we've done. And indeed, the public news outlets have not been, they've not been unaware of this. And you see all sorts of headlines in newspapers about the biggest traffic spike in traffic deaths in 50 years, blame apps. It's apps that are texting and driving, watch out. And so this has been a lot of press here. And it turns out a horrifying number of people use their phones while driving, as noted in this article. And this, again, is a worldwide phenomenon. I want to show you a little bit of an analysis, a research that we did at my company, Cambridge Mobile Telematics, which spun off our research work at MIT on this area. And we partnered with some researchers at the University of Connecticut. And there's a PBS, which is a US TV channel, did a documentary called 3 Seconds Behind the Wheel. And you can see the video at 3seconds.org. 3 seconds is the notion that 3 seconds is the amount of time it takes for a car going at a highway speed to go through the length of a football field, which is about 100 yards. And so this idea, because everyone has a sports analogy in mind, you want to say in 3 seconds, you can travel such a big distance that, that's all it takes. Take your eye off the road for even a second or two, and you're covering, with 3 seconds, you're covering the length of a football field. So we did this analysis where we instrumented with sensors and cameras in the vehicle, and we collected some video data. And these were people who knew they were being measured, who knew they were being monitored with this. And they were told that this was a study, they were just told to behave as naturally as possible while driving. And here's a snippet of what we saw. There's no audio here. I'm just going to play the video, and you can see what this video looks like. So this is about a handful of drivers, and this is what they're really doing while driving. Here's a young lady who's looking at her phone while driving. Perhaps she's navigating, perhaps she's trying to figure out where she's going. She's taking her eye off the road for just a second or two, and you can see at the speed, the distance. I don't know what he's doing. He's having fun while driving. She's holding up the phone to get a better signal, and this doesn't matter if it's night or day. People are doing this while they're driving. Some people are drinking coffee. She's again back on her phone. And then what you see here is quite extraordinary. This woman was actually, she was working multiple jobs and had to eat while driving. So there's a lot of this type of distraction that's happening. So if you do this research, and a lot of people in this field have looked at this research, there are multiple types of distractions in the vehicle. There's manual, which is hands taken off the wheel, or you're fiddling with the radio or something like that, or your phone. There's visual, the eyes are off the road, which is a huge issue. And then there's cognitive, which is you're doing something in the car, perhaps and because of which your cognitive attention is elsewhere. And all of these are critical factors in distraction. So we've done some research again, and I forgot to mention one thing. A lot of this work is not done by me alone. In fact, it is a massive credit to my collaborators at my company, Cambridge Mobile Telematics, and before that, my students and colleagues at MIT. And one person in particular has been a partner of mine for many years in this, Sam Madden, who's a professor at MIT and a co-founder with me at my company. But I owe a huge debt of gratitude to all my collaborators at both these organizations who've really been driving a lot of this technical work. And I collaborate with them and I work with them on this. So I was remiss in not mentioning it before, but that's an important thing to note. So anyway, when we look at the data and do some further research, we've observed something we call the distraction hangover effect, which is somebody's distracted by their phone. And this is data obtained from a very large number of users. We have millions of users now on the platform that I'll talk about a little bit later. And we measure the crash risk as measured by an evasive maneuver that's done by the driver shortly after a phone distraction event, where we use the phone sensors to determine whether someone is interacting with their phone. Just by looking at the data from the accelerometer and the gyroscope on the phone and the screen state, we can figure out if we think they might be distracted. So we compare the likelihood of an evasive maneuver, like a hard braking event where they might be trying to avoid something or something sharp as a sharp swerve. We compare the baseline rate of that to the rate at which those evasive maneuvers or crashes occur shortly after a distraction event. So we look at 10 seconds, within 10 seconds after a phone distraction, the phone distraction ends, and then we look at 10 seconds after, and you can see that the increase in this probability of crash risk or significant evasive maneuver goes up by 75% after a screen interaction, where the driver has interacted with the screen in some way, presumably taking their eyes off the road. And you can see for different types, if they move the phone, which is phone motion, you can see a 38% increase. And a phone call actually has about a 50-something% increase. And we've looked at whether it's hands-free versus handheld, and naturally handheld calls have a much higher likelihood. So there's a hangover effect, which is a cognitive type of effect, where your distraction is ended, but your mind is still not yet back on the road. Your eyes are not completely focused back on the road. And I think what we don't understand is that the speeds we're talking about, the cars, the vehicles, even in two-wheelers, travel an extraordinary distance at substantial momentum within just 1 or 2 seconds. And the shortness of time for a human being, when you transform that into a velocity of the vehicle at even 30 kilometers, 40 kilometers an hour is quite some distance. And I think that's why we see the evasive maneuver. And not all these evasive maneuvers are actually evasive. They sometimes don't make it hit something. So I've taken to calling these phones weapons of mass distraction. WMD, a different type of WMD. And in our data, we found that 37% of individual trips in the United States as of 2019 involved phone distraction, and this number increased. I'll talk about the impact of COVID in 2020 momentarily, because everything in the world has changed in 2020, including mobility. And we found something really interesting in the COVID timeframe, which I'll talk about next. But 37%, over 1 in 3 trips, have significant distractions. This is not just somebody who's on a hands-free call. This is somebody taking their eyes off the road, interacting with their phone screen, moving their phone while driving. And the other shocking part is more than a third of these distraction episodes, I don't call them events, they're episodes, they last for some period of time. More than 36% of these distraction episodes occur at speeds above 80 kilometers an hour. So just think about this, right? 1 or 2 seconds off the road, how much distance it's traveling, and then you take the mass of the vehicle, multiply by these speeds. It's extraordinarily dangerous. And when you talk to drivers who do this, and I'll raise my hand here, you don't even know that you've used your phone. They've become an appendage to our body. And that's just the way it is. And we all know we shouldn't do it. You know, your phones have do not disturb and so on and so forth, but we also sometimes rely on these phones extensively for navigation and for everything else. And it's not that we don't know, it's that we're unable to help it. And the question is, what can we do to get us to start paying attention and start improving our behavior? And the question is, you could have penalties, you could have incentives, and the thesis in this work has been, what can we do with positive incentives? Now, here's another interesting data from the United States, state by state across our massive user base. The left is the distraction events per 100 miles of driving, distraction times, and the right is in 2019. As you go from yellow to blue, it's getting worse. So in 2017, it was about a little over 30%, 33% in terms of number of trips with distraction, and then it crept up in 2019 to 37%. Now, what happened during COVID? So this picture is interesting. I'm going to walk you through it step by step. The x-axis is time. We start in January of 2020, before the world knew about the pandemic. And then we go to March of 2021. And this is data from the United States in aggregate. I want you to start with the yellow first. The yellow shows, and I should say, we took a corpus of drivers, which are the cohort of drivers that have been with our program for a while. So several thousand drivers, I think about 5,000 drivers that have been with us in our programs for an extended period of time. So we're just looking at that sample, which is a large sample of drivers and their overall anonymized aggregate driving patterns. So what you see here in the yellow is the distance itself. So the peak day of driving happened to have been, in our case, a Friday at the end of January in 2020. That has been the peak day of driving in our data set in the entire United States from over the last year and a half. I believe it was January 31st of 2020. That was the peak day. And all of this distance is normalized by that. So the yellow shows the reduction percentage from that peak. And you can see that it sort of sharply dropped. The WHO declared the pandemic in March, and then mileage of driving sharply dropped. And that happened in many countries, including in India. Whenever the lockdown happened, the mobility drops. And you can see that overall, the yellow line shows the mobility, and it's kind of crept back up. We're still not at the peak, but we've come back up. What has changed? The morning rush hour has gone away, but the mobility has become smeared over the rest of the day, but it's overall gone up. The blue shows speeding, excessive speeding above safe speeds, or well above the speed limit. This is typically on highways, 15 miles an hour or more above the speed limit. And you can see that speeding just went off really high. You can see it was a positive percentage over, rush hour went away. And in places like Los Angeles, which are often perennially congested, not Bangalore congested, but, by US standards, quite congested. We even saw times when speeding went up by a factor of 2.5, because previously it wasn't possible to speed, and now people are just zooming. And naturally, one of the things that has happened is that the impact, while the frequency of crashes has gone down, because mobility decreased during the trough of the distance, the severity of the crashes went up quite a bit. And that's because the speeds went up. The orange line in the middle shows phone distraction. That has actually gone up by roughly about 10 percentage points compared to the baseline. So again, people are actually using their phone. And the explanation for this is in our phone distraction metric. When the phone distraction happens at speeds under 15 kilometers per hour at very slow speed, when you're idling or going slowly and looking at the phone, we don't really penalize it. We don't really think of it as a risk, even though it is. And the reason for that is if we start doing that, almost everybody's doing it. So if we did that, it doesn't provide enough of a discrimination between people who are really safe and people who are less safe. But what has happened in the pandemic, again, the speed has gone up because rush hour has dissipated and people are still using their phones. So there's more phone distraction episodes because the speed is higher. So that's an interesting thing. So the problem in a sense has become worse, even though in aggregate, because mobility has dropped, it appears to have become better. So what can we do about this? So, and I showed you a lot of data, and you should be asking, here, Hari, how did you go measure this stuff? Did you put cameras in every vehicle? Clearly, we didn't do that. We haven't put cameras in every vehicle, but we did, what do we do to measure this data? What do we do in terms of the research to collect this data? I showed you the analysis results from the research, but how do we collect the data? So I want to talk to you for a few minutes, giving you the highlights of what telematics is, which is the ability to measure the dynamics of a vehicle and with our work, the behavior of a human driver using data. And what does that data, what is that form of data, and how do we do it in a way that preserves the privacy of the driver? So I want to start top down. I want to say, suppose you wish to figure out the ways in which you determine if somebody is a good driver or a bad driver. One, how would you do it? Well, one way you could do this is to try to ask people if they're good or bad. And indeed, at the start of this work, we partnered with one of our insurance companies. And there's a very pioneering group in South Africa, Discovery Insure, who we partnered for many years. They did a survey where they just asked people, hey, do you think you're a well above average driver? 81% of respondents said that they were well above average drivers. More men, higher fraction of men said they were well above average drivers compared to women, but everybody's above average. When you look at the data, 33% are well above average drivers. So there's a big gap. And that gap where people think they're good drivers, but the data shows they may not be, that's actually the thing to leverage here, because that's the way you get the incentive mechanism in place. You think you're a good driver? That's wonderful. Let's help you prove it. Let's show you some data. Let's show you data that is predictive of crashes. We'll give you a score. You look at the score, and then you're challenged to improve. You're given incentives to improve, such as discounts from your insurer, or you're given rewards for improvement using social gamification or using behavioral science. So that would be the key to how you go about doing this type of work. So how do I measure if someone's good or bad? So here are some risk factors that we and the community has developed. Phone motion, which is using the phone, moving the phone while the screen is on in a way that uses the sensor dynamics of the phone to see if you're doing things like this, or holding it like this, or holding it like this while driving, or just kind of moving the phone around. That's one way to do this. The other thing you could do is to look at screen interaction, which is, are you using the phone in a way that's interacting with the screen? We've developed machine learning algorithms that take the data from the accelerometers and the gyroscope of the phone and train it to determine if somebody's tapping on the phone. The sensors on your phones are quite sensitive these days. They're able to collect data at many samples per second, and we can then apply signal processing and machine learning to determine if there's a screen interaction like a tapping. You can then take the phone sensor data and convert the sensors of the phone, which are in the axis of the phone, in the 3 axes of the phone. There's a 3-axis accelerometer and a 3-axis gyroscope that can tell rotation. And you can convert that into the dynamics of the vehicle by correlating it with speed of the vehicle that you can obtain from a position sensor, like a GPS sensor. And when you do that correlation, you can determine the fine-grained acceleration and braking pattern of the vehicle. And a pronounced pattern of hard braking is a sign of evasive maneuver, and potentially is a signal that someone is inattentive and could be at risk. And of course, you could combine these factors together, the hangover that I talked about. You can make more advanced risk factors. You could look at risk speeding. You could look at the type of roads people are driving on. You could look at swerving and cornering. So all of these could be hypotheses that you could measure. And then what you have to do is to develop a model that determines whether, for each of these hypotheses, use the scientific method to determine if in fact it is a predictor for safe or risky driving. How do you know if something is safe or risky? Well, one thing you could do is use the same sensor technologies to determine if someone has been in a crash. When there's a crash, there's an enormous G-force, which is to say a disruptive braking event of a high magnitude. Sometimes the vehicle spins, so you'd see a yaw rate on the spin. And then by partnering with insurance companies who apply our programs, you can correlate it with claims data that come in to develop these models. And when you do that, you can build charts like this that take risk factors individually as well as in combination and produce what is known in the actuarial science area as a lift chart, which is the predictivity, which is the relative crash frequency as a function of your risk factors. So you take all your users. Let's say that you have a hypothesis that somebody who has a lot of speeding or a lot of hard braking might be a higher risk driver. You come up with a score. You come up with some algorithm that determines the way in which you score those people on that factor or a combination of factors. Then you rank them from the best to the worst. Then you take each group of them, say every 10% or 20%. So take every 10% of the drivers, the top 10% according to your score, the next 10% according to your score, and so forth to the worst 10%. And for each cohort in that decile of 10%, you look at the empirical data. What was the fraction? What was the probability of a crash or a claim in each decile? If you've invented a good risk factor, this scientific method will show you that people with a certain score in your decile will have a probability of a crash that depends on that score. And if you have a good score, a high score should be, if that signifies a safer driver, it should mean that the crash rate should come down. And you can plot, like I've shown here, these curves. And then you could look at the ratio between the worst to the best or the best to the worst and ask what is the difference in the probability. And that's known as the lift. And things with the higher lift are more predictive, and that's the nature of the science. So we've been doing this for years, and our insurance partners have been doing this for decades. Working with us over the last decade, they've been doing it with telematics data, and it is hugely predictive. We've also filed these scores with regulators in 45 and US states, and hopefully soon all the US states. And internationally, we work with partners to file these scores with regulators, so it becomes a part of how people are rated for the purpose of insurance pricing. And that's a huge positive incentive, because now we're able to price insurance not on the basis of somebody's age or somebody's gender, which is sometimes used, or income level or education, which are all correlating factors, but not causative, but fundamentally use causative factors to determine how to rate people. And that's really an interesting aspect of this science. Now, where does that data come from? How do I know if something is a braking event or a distraction event? How do we do this? And the answer to this question is based on raw sensor data. Telematics is rooted in sensory data, and that's really where I fit in from my background. Over the last 20 years, I've worked in this area of sensor computing as one of the areas of work that I've been involved with, and have really been fortunate to have been in this field right from essentially the beginning of that field. And historically, this has needed expensive hardware like black boxes or other hardware devices that were fit in cars, and they were quite expensive. Our work pioneered the use of smartphones for this data. And here's an interesting, and I think I find this a gratifying irony or gratifying paradox. These smartphones are largely responsible for that rise in traffic crashes in the US and I believe worldwide since 2009, and the rise in pedestrian injuries and fatalities and bicyclists. Let's use them as a force for good, because they also contain the sensors. They contain the building blocks that can allow us to build the science around understanding driving risk at massive scale, because there are, I believe, 5 billion smartphones now. Every one of them has accelerometers, GPS, gyroscopes, and so on. And in addition, we also have built a small device called a tag, an IoT device shown in this picture. It's a 5 centimeter by 5 centimeter device, attaches to the windshield and connects over Bluetooth to your phone automatically. And it has a lot of nice properties, including it's a mounted device that is very accurate, high frequency accelerometers, providing even higher quality data, and is able to measure the data even when the phone is not present if somebody drove the car without the phone. So that combination of an app only or an app plus tag allows us to scale. And it's allowed us to build a platform with millions of users. To date, we have shipped 20 million of these tags worldwide, and it's something that's providing a very, very exciting source of data. On the phones itself, you have accelerometers, GPS, gyroscope, barometers, which are actually used to helpful to understand if a crash has happened with an airbag deployed. The barometer on your phone is able to tell, you can analyze that data and come up with algorithms that can determine from the pressure differential and the variation whether an airbag might have deployed. So it's fascinating and frankly something that's getting even more exciting, because every new generation of phone comes with more and more exciting sensors to be using for these purposes. My journey here from academia came in from the MIT Cartel project, where we instrumented vehicles prior to the availability of iPhones and Android devices, starting from 2005, working with my students and my colleague Sam Madden, we had this research project that had a lot of academic successes. We partnered with Boston area taxi companies and several users, and every day we were mapping traffic conditions. Now, today we have Google Traffic and Waze and all these applications. In 2005, we were among the first to do this and publish this. And every day we were able to update real-time maps for the Boston area showing traffic. And this is a picture on the left I've shown, which is actually 15 plus years old in terms of what we were able to do then. The iPhone came out and we were able to write some applications for the iPhone back in 2007 to do traffic measurement. And we partnered with the local taxi companies in the Boston area to obtain this data at scale. And then we also did an interesting project called the Pothole Patrol, where we were able to instrument this in 2007. We published this paper in 2008, where we were measuring road surface conditions and every day putting out a map of the Boston area saying, here are the top 40 potholes which need to be fixed in the Boston area. These were potholes that people were unable to avoid. And to do that, we were using really high quality sensor data from accelerometers, and that quality of data is now available on your phones. And we were able to correlate that with GPS data to determine this. The path toward commercialization of this research came because around 2009, coincidentally with the recession, I started thinking about how to commercialize this and started learning about road safety and road hazards. And it occurred to me that all this technology we developed on commodity mobile devices could provide a pathway to replacing expensive hardware that were preventing the ability to scale the collection of data and preventing the ability to provide incentives to drivers, because we were entering a mobile world where mobile was the way to engage users after their drives, to provide these incentives. Because everybody's got several minutes a day, they occasionally look at their phone. That's the way to engage drivers and provide these incentives. And mobile provides both the sensor scaling technology as well as the ability to engage drivers, and all that was needed was the algorithmic capability. So currently we support over 3,000 different phone models, and I think it provides a way to obtain this data at massive scale. The phones are all somewhat different from each other. And most of these are Android devices in the models that we show, and this is actually a picture showing the area of each of these rectangles is proportional to the number of devices of that type that we have. And there's a long tail of devices, and we normalize the data and support every single one of these devices shown here. Basically, what's needed is an accelerometer, GPS, which is available in most devices. And if you have the tag, you don't need a gyroscope, but if you have a gyroscope, then you can get phone distraction data as well. So it's an accelerometer, a gyroscope, and a position sensor. And today that's highly commoditized on every phone. The tag itself is a peel and stick. It's no wires, no cables. You remove the peel, you stick it on the windshield, and it lasts on a battery for about typically 4 years on personal driving, and it augments the sensor. So that allows us to scale. It augments the sensors on the phone. So that allows us to scale the data collection. Then we have algorithms that convert the raw data into insights so that the user doesn't have to do anything, and the user can do anything with their phone, hopefully not dangerous things, but they could keep the phone in their pocket, it could be moving around, they could give it to their kid at the back, all of that is fine. The trip recording happens in the background. It's not that on every trip you have to do something. We use the sensors on the phone and the capabilities of iOS and Android to use that to automatically start recording trip data at high frequency from the accelerometers while somebody is driving. And we do it in a way that has very low battery drain. This is technology we've developed over the past many years that does it in a way that does not have a massive battery impact. And then algorithms convert the raw data to precise trip details. What is the braking pattern, the acceleration pattern, the velocity of the vehicle? Different types of phone distraction and tapping metrics around the understanding whether the driver's eyes are off the road or the type of dynamics they're interacting with their phone, how they're interacting with the phone. Estimating mileage and speed, sometimes when there's no GPS data, we have algorithms that use the inertial sensor data, accelerometer data to do this. And you can't just integrate the acceleration to get the velocity and integrate the velocity to get the distance, because the errors then compound and the numbers are off. So we take that fundamental physics problem, but we do it using machine learning, where we have this function mapping that is trained and learned through a machine learning model that does better than double integration because of the errors. We have map matching algorithm that produce accurate trip trajectories and speeds using noisy position data. Machine learning to determine what mode of vehicle are you in. Are you in a bicycle? Are you in a two-wheeler? Are you in a car, airplane, boat? What are you in? And so that you can identify the driving alone. And then, are you a driver or a passenger? Turns out machine learning can be quite successful at that, using some properties of the type of behavior people exhibit with their phone when they're a passenger versus a driver. And last but not least, use the same sensor data to detect crashes in real time so you can help people with roadside assistance. So that's the scope of the type of technology we're talking about here. So now I want to spend a minute or two, a few minutes, just telling you how to make drivers better. We've shown you how to do the measurement. Now, how do we make people better drivers? So one thing you could try to do is to institute laws. And this picture shows 4 different US states, slightly before and slightly after handheld laws were introduced. The map on the right shows where these states are in the US, and the colors show the toughness of the law. So 3 of the states had tough laws and 1 had a weaker law, but all of them didn't have any laws, any significant laws against phone use and the phone distraction, and then they instituted these laws. And what you see here is that in some states, there is an impact that's happened. It's a noticeable, but not a major impact. But it depends a lot on the ability to enforce, and that is the weakness. And the top state here, the top curve is Rhode Island, which is a small state, but in our analysis has always ranked within one of the worst states by way of driving. Enforcement, even in that small state, has turned out apparently to be quite difficult. And you can see that it's had very little impact. And so any law is only as good as the ability to enforce. And that, with phone distraction, is very difficult because the phone could be on somebody's lap. It's very difficult to tell. It's not like speeding where somebody could have a radar and look at it. It's very difficult to enforce this. And so that's where incentives can apply. Incentives don't replace penalties, but I think they play a significant role. So what motivates drivers to change? We've asked them, we've done consumer surveys asking them these questions, and 39% respond saying discounts on insurance. 29% said rewards, and there's lots of other things. There's not a one size fits all. Different people are motivated by different needs. They're motivated by different things in terms of how they want to respond and improve. And so that's part of what is important about the mechanisms that we provide, many different types of incentives. So for the past many years, we've partnered with many insurance companies. We have over 65 enterprise programs around the world at Cambridge Mobile Telematics. The largest telematics program in the world, or in the US certainly, and probably one of the largest in the world, is from State Farm, which is US's largest insurer. This is now a public program. I'm going to show you the way in which I'm going to just show you a small TV commercial. It's also available on YouTube, just to see how they market the program, and the users just love it. This app on the App Store has a 4.6 star rating with close to 100,000 reviews, and it's really based on understanding. We work with them to understand the behavioral science. Now, the driver in this ad is a NFL American football player. His name is Aaron Rodgers. The best way I would describe him for the Indian audience is he's like the Ravichandran Ashwin equivalent. You know, very cerebral guy. He recently was the host of Jeopardy, which is a TV quiz show, and he's an extraordinary football player, just amazing. So, and its closest resemblance is with Ashwin, the cricket bowler. So I'm going to play this. I hope the audio works, and you can see how this program is marketed.
So what's the deal with the app?
So the safer you drive, the more money you save.
Well, bad news, State Farm, because Aaron doesn't know how to play it safe.
Light it up! It's yellow, floor it!
That's enough. What? Don't mess with my discount. What are my other options?
Get a discount up to 30% with Drive Safe and Save from State Farm.
So you could see the type of positive incentive that it creates when you have the right type of marketing, very simple to understand, drive safe and save. Our own motto is drive well. We've done contests where the motto is drive well and win. And I'll talk a little bit about that. From an insurance perspective, telematics scoring fosters equitability because it's fundamentally based on how you drive. It's not based on demographic factors. It's not based on things that you don't control. If you have a young driver, a teenager who's just started driving, for example, or someone without a lot of experience, almost by definition today, their insurance rates are high. And many of them could be good drivers or are good drivers. How can you tell the difference? And many seasoned drivers are not as good. So how you drive is about causative factors, not just correlations, controllable factors, because you can now put the phone away because you know to not do that. Be told what the risky driving patterns are from data science and use that to become better and then save money. It's a win for the individual, it's a win for society, and it's also a win for the insurer because they can then avoid a lot of expensive claims. And it's non-discriminatory. All insurance is differentiating, right? No one wants everyone to pay the same price for insurance because then there's a moral hazard, right? Everyone's just going to be terrible, except of course they're worried about their life, but people don't have an incentive to get better. You're relying on the laws, you're relying on traffic tickets, you're relying on punitive things. But with a non-discriminatory factor, you can start having positive incentives to get people to be better drivers. And this is just showing that income level is not correlated with good driving traffic. And this is important because in many parts of the US, aspects of income are used in determining the insurance rate. It turns out it's correlated, but it also turns out there's now some pressure in society to go with less discriminatory factors, and telematics could be a part of the answer. But it's about personalized incentives. So the programs we've created have family sharing, where you have younger drivers or families, you can keep track of each other's driving and use peer pressure to improve. In my own family, we use this with our insurance company, Plymouth Rock, with Road Rewards. It's a reward-based program with family sharing. We can look at each other's driving. And my daughter has been quite keen on telling me whenever her score is better than mine. And I think that's a way by which we can all improve. And I can tell you she's become quite an extraordinary driver relative to she's not the worst driver in our family. And I will refrain from talking about who the worst driver in our family is. There's leaderboards where you could compare with other people and then consummate it with rewards, where you drive safely for a week or two. You have a personal challenge, for example, say, look, drive 50 trips without touching your phone and you can be eligible for a little bit of currency or money that goes into a reward program. And if you accumulate enough, you can get a gift card, for example. And that's the sort of program that we're on with our insurance. It's just really allows us to improve, and it's a win for everything, for society. And engaged drivers, engaged users who have even a static, simple reward program that honestly doesn't cost a lot of money to put in place, improve driving behavior. In this picture, the lower the bar, the lower the length, the taller the length of the bar, the better the improvement. And you can see that by day 14, you see an improvement. This is on average across all drivers, a reduction in risk as a function of the start of the reward program. And then you stop the rewards and slowly it'll start regressing, or maybe quickly starts regressing to some degree back. So you do need continuing incentives. But the trick is to figure out what motivates the individual, because some people are motivated by competition. Some want the discount. Some are just want the spot rewards. My own, if you have a young driver who isn't paying for their insurance policy, they have no idea what the insurance costs, but they like that gift card to Spotify or Starbucks or whatever they can be incentivized by. We've also created an interesting mobile app, and this is important because I would love to partner in bringing this app in the Indian context, and I'll talk about what we've done in the United States. This app enables the hosting of social driving contests. We did the first one in partnership with Discovery Insure in South Africa in 2014. It's a place with a lot of risky driving, not that different, honestly, from India. And we have worked with Discovery to bring positive incentives through them to the community. We got 70,000 users in that first driving challenge in South Africa. It was an extraordinary success. And that got us into this mode with a variety of American cities, Boston, Los Angeles, San Antonio, Seattle, and others, to bring this program. And we've now created the Safest Driver app, which is something that we could co-sponsor and bring a sponsor in from India to launch a contest very, very easily. And here's the sort of way in which it works. It provides a variety of different incentives, leaderboards, actionable feedback to tell people how to drive better, trends and streaks, and so on. And there's a grand winner at the end, and you could have winners every week or every 2 weeks based on a leaderboard. And this has led to some enormously strong successes. And there's a virtual currency in the app that could be redeemed for, a leaderboard score or for tickets that you could then use to do other things with. So it provides that social capital, and people want to be part of the safe driving community, create a community of safer drivers. We launched the first one in the United States in Boston in 2016. We did another in 2019. This is a picture of me with the mayor of Boston and my partner, Sam Madden. And Boston is not known for its best driving. There are some words that I cannot say in polite company about how people refer to drivers in Massachusetts. But this program had some pretty good successes. A 47% reduction in phone distraction among the top 25% of most improved driver, 37% reduction in harsh braking. And we recently won an award from the Federal Highway Safety Administration, a recognition as a Vision Zero success story. Vision Zero is a program to try to eliminate traffic deaths over the next decade. And this was viewed as one of the big successes. I now want to show you an example of the outcome from Los Angeles. This is by the Deputy Mayor of Los Angeles talking about their experience with Los Angeles' Safest Driver program. And my dream is to bring this to every city in India.
Well, Los Angeles is a city of automobiles. People here love their cars, drive a lot. So one of the biggest issues that we have is the epidemic of distracted driving. We needed to find a creative way educating drivers to be safer drivers. One of the key things we did with education is a fun, competitive app called LA Safest Driver. It was developed by Cambridge Mobile Telematics for the city of Los Angeles. And so through LA Safest Driver, we got tens of thousands of people to participate in competing against one another to try to be LA's safest driver. It was pretty clear that among those people that downloaded the app, became conscious about driving better, that actually happened. That speed went down among that group of people, that distracted driving went down among the group of people that downloaded the app. And in the end, that meant fewer accidents, fewer injuries, which is enormous benefit to the city. So I would recommend to any other city, state, other jurisdiction considering what their suite of opportunities are for driver education, to consider teaming up with Cambridge Mobile Telematics to develop an app and to do something similar to LA Safest Driver.
In the last minute, I want to talk about how this can also help in a crash, because crashes are not something that you can completely eliminate with this technique or frankly any other technique known today. And you could use this telematics data within 1 minute to set up a roadside assistance and use analysis on that data to connect it with a roadside assistance service for emergency assistance. I am running out of time, so I'm not going to talk about how this works. I do have some videos that maybe I'll post later that people can check out. And there's science involved in how we get this measurement. We do both obtain data just in situ from the field, looking at accident crash data and claims data from our partners. But in addition, we do a number of controlled crash tests by just having the cars crash into each other. And then within soon after crash in real time, we can use artificial intelligence completely to produce a crash reconstruction report, such as is shown here. This is completely automated, where there's all this information about what happened just before, during, and right after a crash that could then feed into a score that's a severity score that can be used to determine whether to send roadside assistance and then start in the claims process itself. So you can help improve the way and the time and the effort it takes to process an insurance claim. Let me conclude by talking a little bit about the future. The future is beyond scoring and crash and claims for insurance. While that still remains a big open field, there are 1.4 billion vehicles in the world today. It's a 40% increase over the last 10 years. And the increase in places like India is even more dramatic. We want to get to using these types of technologies to all of these vehicles that exist today. But in addition, there's a broader scope of safety for the entire mobile world. Pedestrian safety, bicyclist safety, etc., using mobile sensing, AI, and the incentives from behavioral science. So a variety of new data sources emerging in the Internet of Things, video, LiDAR, wearables, and connected vehicle data. It's an exciting and ongoing area of research to look at the impact of driver assistance systems. When the car brakes automatically to avoid something, how do you think about that in combination with the human? There's a lot of transitions that happen between these modern cars, which are somewhat automated, and the human. And those transition points sometimes tend to be weak. And over the next decade, probably by the end of the decade, we're on the road to autonomy. And at that point, all insurance will be based on telematics, based on an external in situ assessment of the quality of the sensors in those vehicles, AI performance, and software quality. And I, for one, do not believe that self-driving cars within the next decade or even slightly thereafter will eliminate all crashes. That is a tall order, because if you believe that, you will believe that all software is infallible, all artificial intelligence is infallible, and the sensors are error-free, and that has not happened. We can hardly get our email and our software programs that we worked on for decades to run properly without errors. And in the transportation context, these vehicles are making 1 million or more decisions every year. So an error rate of one part in a million doesn't cut it. We're still far from building those systems, although it's an exciting area. And frankly, telematics will have an even greater role to play in that world, because the assessment of that world in a hybrid world where you have autonomous, semi-autonomous, and human mobility will be all about using data science and using data to understand how to measure, how to improve, and how to help when problems happen. So with that, I thank you for your attention. I've enjoyed this, and I hope you did too, and I look forward to the discussion.
Thank you, Professor Balakrishnan. This was a tour de force, Professor Balakrishnan. I mean, for over 45 minutes, we really listened to some high quality data analysis and inferences. So, you converted me, for instance, who was quite skeptical about what big data can do and how it can make a difference to driver behavior, into what you actually showed by way of measurement and then by way of actually shaping driver behavior, okay? So thanks very much for this excellent presentation, and I'm sure all the participants who are gathered here will also join me in thanking you. There are many questions that have come, which is in the question and answer box, and I'll go to them in a minute, except to pose just a couple of observations that I had for your quick reaction before we go to the Q&A. You gave us a very good idea of what telematics is and how you brought it about from 2005 onwards. But till now, basically the thrust is on insurance companies, right? The way they determine premiums and the way they give incentives and rewards to motivate and pattern behavior of drivers, right? Am I right in making that inference?
Yes, that's correct.
Okay. So beyond this, is there any kind of application of this?
Yeah, that's a good question. So first of all, I think insurance is a commercial way in which you can bring this into society. But partnering with governmental agencies and private-public partnerships is an equally important way. I mean, I'll give you one example, right? We've done these safest driver contests in municipalities, and we partnered with the Boston twice. Boston City. And some of the conclusions we obtained from that, from the data analysis, have helped with city planning. There was one example where they moved a bus stop to a different location because they found that the bus stop was in a place where the data showed that a lot of people were having heartbreaking events because they were avoiding it. There was some sort of lack of visibility. So that's an example where this data can be used for city planning. Another one is we found locations where people are maximally distracted by their phones or maximally inattentive. And now the city can put signposts there, like digital signposts saying, put your phone away, or you could do it later. You can do this based on data. So it turns out there's a bridge in the Boston area connecting Cambridge to Boston called the Longfellow Bridge, where there's always been that. Now, nobody knew that. So data can help with city planning and government. And of course, today we use this data worldwide with traffic. But I think that being able to support the public sector in a public-private partnership is important, because often the private sector has the ability to collect the data at scale. The public sector has the ability to deploy the technology. And I think partnering in places like India would be a really good way to bring this into the hands of the public.
Okay. Professor Balakrishnan, I wanted to ask you a question about distraction and the correlation between distraction, which you have in the United States, and the kind of individual way of life that is supposed to exemplify Americans. As also any correlation between educational attainments of drivers, income levels, and the fact that in most cases they may be single drivers, meaning single occupants of the car.
Yeah, that's a really good point. So I don't have really strong results on whether there is a correlation between educational level versus, say, phone distraction, but I don't believe there is. And frankly, if anything, there might be an opposite. There might be that the more educated someone is in a degree sense, they might actually be worse off, because they tend to be highly multiplexed often in their lives. They're dealing with a lot of different things. And frankly, that is one of the problems that we do have in all countries as a society. We're just doing too many things at once, and we're using the phone as an aid to do more things at once. But given the fact that 37% of trips have significant distraction, and I didn't talk about this, but over 80% of drivers seem to have distraction event at least once a week. I think it's just widespread. Yeah, I don't think there's now the individual versus collective is pretty interesting. Anecdotally, we have found in the COVID time, when the distraction went up, we did find on the holiday weekends, it came down. The Thanksgiving weekend, when people have a lot of driving, Memorial Day, Christmas. So one of my colleagues speculated that it might be because there's a lot more group driving. It may mean they're not on their phone. It may mean they're still distracted with some other thing, but I think you have a good point there. I am quite eager for us to work with in the Indian context here with this technology, because the data will tell us the truth. It'll either confirm or invalidate hypotheses, and it'll tell us what hypotheses are the right ones to be going after.
Great. So now I have a third question, Professor Balakrishnan. I was very intrigued to see this tag that you have, this peel and stick, okay? Now, without going into the technological background of that, how you arrived at it, do you think that is capable of quick application even in an emerging country context like India?
100%. By the end of this year, we'll have a version that will be very useful in the emerging country context. It'll be quite an autonomous type of device that would be very, very useful. Yes. We have deployed the tag already in many countries. So there's nothing fundamentally stopping it, but there's some changes we're making to make it work in places like India better.
So even, theoretically, the transport authority can use this tag to give points to bad drivers.
Yeah, or give points to good drivers or penalties to bad drivers. 100% right. Yes.
Something like that. They can grade driver performance.
That's right.
And take action for those drivers who don't make the cut. Something like that can happen?
It could. But I do believe that one of the lessons we've learned from an incentive structure is if you tell people that here, use this technology and you'll be given points for bad driving, the incentive to adopt is not there. But if you say use this and you'll be given something for good driving, everybody thinks they're a good driver. I bet you in India, you do a survey, 90%, 80% will say they're a good driver.
Yeah, like in the US, right?
Yeah, because everyone's very confident.
Okay, I have two more questions and then I'll pass it over because there are now 34 queries that I see in the question and answer box. So tell us a little bit more about the South African experience, because that would parallel what we go through in our country the most. So just tell us quickly about South Africa.
Yeah, so we've believed in these behavioral incentives for a long time. And Discovery Insurers, a company in South Africa, has been a long-term partner of us, and they have a lot of expertise in bringing this. We did it first as a driving contest, and now as an insurance company. They use our technology and they build very interesting incentive programs that have really made their roads safer, and certainly for their users. And I think they're making a big mark on society. Bringing those technologies to India is something that I think is very within the realm of not just possibility, but high likelihood.
Okay. And finally, Professor I want to ask you about the Safest Driver app, and I also heard the endorsement from the Deputy Mayor of LA. So, is that something that you can quickly bring into fruition in, let's say, India?
Yeah, it'll take probably 60 to 90 days to make it work, but the app is already usable. We just need to set up the program and the contest. So people can download the app today from India and check it out. There's not any incentives in it. It's just a good app, but yeah, it's really ready to use. And I would love to partner with authorities in India, pick a few cities.
Okay, so I'm now going to the questions, Professor Balakrishnan, and I have 35 questions and I have 10 minutes. So help me to apportion time between all these questions using telematics.
So maybe we start with, let me see, not all of them are questions. Some of them have been answered,
Okay,
I guess.
there's one question I want to ask you.
Yeah.
It's from Gopal Hosur, a distinguished police officer. His question is, accident investigation is contentious in many cases. Has this technology helped investigation agencies?
Indeed, it has. It has helped insurance companies understand what is known as first notice of loss, or FNOL. It provides with artificial intelligence on the data, you get an unbiased storyline of a crash. And I showed an example of a crash reconstruction report. It avoids the eyewitnesses. It avoids the who, what happened, who said, he said, she said. And it really provides some valuable unbiased data. It is being used for that purpose. And I foresee that it'll be used in a far greater scale, especially as the technology and experience matures. That's a very good question.
Okay. There's a question from Shamal Chandra. Do you believe that gamification can always be fair and avoid legal ramifications?
As I tell my children, nothing in the world is perfectly fair. It's a question of degree. It's a question of people feeling that it's fair enough. So, I mean, yes, I do believe gamification can be done in a fair way. Legal-wise, you have to conform with the laws of the country. You have to conform with whatever laws of the land there are. But our goal is to put the user in control of their data and keep privacy front and center of mind. But I do believe that how you drive is fairer than other known ways we've developed so far as a society and as an industry. So I do believe that it is fairer than most, but is it perfectly fair? No, but I don't think anything is. We're just striving toward it.
Okay, so question from Harish Kannuri. Can telematics help night drivers if they are feeling sleepy while driving? Can it help night drivers?
Yes, this is a brilliant question. We have some video products that we've released recently with both sides cameras, and we're putting it in the market for commercial and like ride sharing drivers like Uber, Ola, Lyft, etc. could use it, and they drive a lot. From the phone data alone, it's a pretty difficult task, but there is some machine learning work that could be done to try to understand if someone is fatigued, someone is driving in a pattern that indicates a drowsiness, but it's a tougher and largely open problem. But it's something that I do believe can be tackled, but I don't believe anyone has solved that with just the phone data alone today.
Okay, there are two questions from the ISF team. I have to give it some priority, right?
Right. Well,
does your app ensure that the data it sends is not tampered with?
Yes, it does. The tag data is secured between a secret that's known individually to the tag and to the server in a tamper-resistant way, so the data can't be tampered with. The phone data, you do your best. We have some ways to determine if it has been tampered with, but ultimately it's a device under the control of the driver, of the user. But we have made it difficult to do it. But you cannot make it impossible, because fundamentally it's a device under the control of the driver or the user. But most people won't know how to really break it.
Okay, there's a question from Mr. Naganand, who's a very distinguished lawyer. What incentive can be built in for drivers who drive without license and general indifference to following laws?
I wish I knew. I mean, I will say that I obtained my license in Chennai when I was 18. Okay. I had about probably an hour of driving on the streets before that. I mean, I did well enough to drive the 50 yards to get my license. And then I learned to drive really well in the next few years. So I don't know. I think that, for example, if one created a contest among young drivers, and we do that with teen drivers in the United States who are in the process of obtaining a license, create a driving contest for people who are in the license thing. You give a grand winner to the best learner based on the data. Everyone wants that thing, right, to win the prize. You give one prize, use the money that way. Then I think people who are learning will participate. They'll want to show that they're good because they have that ability to win the jackpot. It's the same principle of the lottery. That's why people participate. Everybody thinks they're going to win the lottery. And this is a skill-based contest. So that's the way forward, I think.
There's an interesting question, Professor, on autonomous vehicle technology. Is it safe to have human drivers be supplemented, assisted by autonomous vehicle technology?
This is a big open question. I don't believe anyone really knows the answer because the risk could be at the transition. The trouble is that the more the technology does, if it doesn't do everything, but does enough, then the human attention goes away. And then when you need to take over, you're not paying attention. So this is a big open question that I think the community is grappling with as to clear indications of when the technology is in control and when the driver is in control. If it is unpredictable, or if it is largely technology, but occasionally human, the human's going to not be able to handle it because, you know, it's going to be like, you're not going to pay enough attention. So I think this is a good question. I do believe that sort of telematics we've been developing can help because it provides a data-driven way to understand when the human should be prepared.
Okay. Is telematics practically possible when roads are bad, that is potholed, and they are limited in width?
Yeah, absolutely. In fact, you can even use this, as I did in our research before, as we did, to figure out where the roads are bad, and you can normalize for that in the driving risk. Because ultimately, it's the science is rooted in correlating with crashes, correlating with claims data. And we have run in some very bad conditions. And some of you may not have been in parts of the US. I can assure you that there are parts of the neighborhoods in Boston area where they will compete with the worst roads in India for the worst road category. So bad roads are a worldwide phenomenon.
Okay, here is a question relating to buses. You know, Professor Balakrishnan, we have about 6,000 buses in Bangalore, mostly in the public sector. Question is, can we apply Cambridge telematics device on bus fleet as well, like the buses moving in a designated lane for buses?
To understand lane conformance, typically I believe you would need video today because the quality of the GPS on commodity devices is often not good enough to determine that level of precision. That itself will change in the next few years based on some technologies that I'm seeing coming down from industry and researchers. But then the solution to buses and fleets for what you want is video. And I think video is not going to be that expensive relative to the rest of the costs of the bus. And we provide such technologies and others do as well. And we provide some machine learning to understand this aspect of lane conformance.
Speaking about the Bangalore context, I mentioned to you that 70% of the vehicles in the city are two-wheelers.
Yes.
So the question here is that, you know, this brings different factors in the picture, and might we need different measures apart from four-wheeler driving? Is there anything in the pipeline that is in CMT on this front?
Yeah, this is a great question. Theoretically, the data we provide and the analysis should work, but it won't work without obtaining real-world experimental data. I mean, I'm a strong believer in running the experiments, getting the data, building the models, running the experiments again, and you keep iterating. The raw material is there, but the models we have right now do not really work very well for the Indian two-wheeler context. But there's no fundamental roadblock. We need partnerships to do this work. We would like to collaborate to do this work.
Great. So do insurance companies in the US disallow claims for accidents caused by driving with distraction?
No, yeah, they don't. No, they, legally you cannot disallow a claim. Somebody has to pay for it. So if someone is insured, the insurer has to pay for it, and then it counts against the insured person. The question you might be asking is a good one. If you are proven to be distracted, does that then change the liability? And my understanding today is no. I don't know how that will shake out in the future, but no, that's not, to my knowledge, not. It's not used in any way other than to understand better what's happening. Sometimes, if an insurer knows that a given driver, their driver is at fault, they might take it upon themselves to try to process that claim quickly and to pay the other party's expenses rather than go through some more expensive litigation later. So there is a benefit to an insurer even to know that their own driver was at fault, because it prevents a more expensive litigation, medical fees, etc.
With self-driving cars becoming the future, will telematics become outdated?
Yeah, I saw that, Anshuman. Quite the opposite. Quite the opposite. Telematics will become the fundamental way. It will no longer be how old is somebody or what education they have. The evaluation of a telematics vehicle about how good it is on the roadway will depend on how it performs in the real world environment, and having scalable, observable technology that can evaluate the quality of the sensors that those vehicles are using, the quality of how it's behaving in the real world condition. How good is the AI that it uses, and how good is the software? It's going to be all telematics. And that's really where the future, in my view, is going. Crashes are not going to go to zero. That's just, not in the time frame of 15 years. Autonomy will hit at some scale over the next decade or so, and we'll start to see it. But the world will have lots of other vehicles. In the US, the median lifetime of a car is about 12 years. In places like India, it's even more. The generational time is long. And even in a world where there's lots of autonomy coming out from the factory, there's a time scale here, and there's going to be non-autonomous vehicles driving. And just think about, in India, it's even more so than here. Think about the number of times when you drive, you are reading the intent of the other driver, of the other vehicles on the road, of the other pedestrians, everything. There's eye contact, there's intent. AI is far from understanding intent today. It's absolutely, we need some breakthrough AI to understand human intent. It'll happen eventually, I believe that, but it's not happening in the next 10 to 20 years.
Okay, the new generation cars have sophisticated entertainment systems within. These can play a major role in distraction. How can we handle such distraction from drivers?
Right. We need to incorporate that in our overall understanding of user distraction. And I think obtaining data on the interactions that drivers have with those systems to really do experimental tests is important. One thing I've learned over the last 20 years is you cannot just stick to lab tests, control tests in the lab. You have to do science in the real world, which is infinitely more varied and complicated. And I think platforms that enable those experiments at scale are the way we're going to understand it. So there may be hypotheses that they are safer than phones. They probably are. But what are the Achilles heels of those infotainment systems? They certainly are there. And we need that real world data to understand. And that's the way in which our work has been done. And I would encourage people working on infotainment to apply that same work model.
Professor, this is a final question from my friend Prem Chandravarkar. It bears on ethics. Many digital technologies have immense benefits while simultaneously creating problems in privacy.
Yes.
Participating in such a program can involve surrendering data on your movement, which can be correlated to information on other aspects of life which you may not wish to disclose. What privacy safeguards can be built into this technology?
This is an excellent point. So at our company, CMT, as well as in my research, we have focused a privacy front and center. So we have a very simple privacy policy. The data shall not be shared with any third parties. It's between the driver, us, and if they have and the insurance company, if they have an insurance program. If it's a city contest, it's just between us and the driver. And the drivers have the ability to delete the data, the locational data, for example. There's no data sharing that's done, and the data has to be put to some, you have to define what the data is going to be used for and make it very clear to drivers. In addition, we've created a privacy board at CMT, led by some eminent, staffed by eminent legal and ethical scholars that help us formulate the privacy posture and the privacy compliance that we take on as a company. It's an incredibly serious issue. And internally, our model compass is do unto the data what you wish to do with your own data. Treat it like it would be your data, but it's absolutely important. And it's important to communicate to users exactly what the data will be used for and for no other purpose.
Professor, there's a matter raised by Praveen Chandra Shetty that's on your Q&A, which speaks about some research he's done, and he wants you to go through it and see if it's applicable in Boston, okay? That's the first, Praveen Chandra Shetty. Now I'll end there and then ask you, we still have 2 minutes to go by the deadline of BIC. Any closing comments, Professor Bala, before we wrap up?
Well, it was a privilege and an honor to be with you today and to see so many people participating. And I'm looking forward to seeing this session on YouTube or whatever the forum we put it in. And really my goal here is to try to explain the science and the work, commercial work that we've done, but really to extend a hand out to people in India who have the influence and the authority to try to bring such programs into India. We will learn together, we can collaborate together, and we will figure out how to use these types of approaches to improve driving quality and safety in India as well as the rest of the world. So again, thank you very much.